Hello everyone. Today we are going to discuss the chapter Circles from Class 10 Mathematics. This is the Google form shared by DDP Office South Bangalore. Here you have name and school. You have to fill that credential based on the school you are studying. So let us discuss the questions in this Google form. The tangents drawn from external point of a circle are, so there are four options given here: equal, not equal, parallel and perpendicular. So this is the theorem in the textbook. I'm not going to explain the theorem in detail. I will just show using the diagram. So there are two triangles. PAO is one triangle and POB is another triangle. According to RHS congruency, these two triangles are equal. R means right angle. Angle A and angle B are equal in these two triangles. Hypotenuse. PA and PB are hypotenuse in these two triangles, and side PO is a side which is common to two triangles. So according to RHS congruency, these two triangles are congruent to each other. As per CPCT, I can write PA and PB are equal. PA and PB are equal. Here PA is a tangent and PB is tangent. Tangent means which touches the circle at only one point, and P is the external point of a circle. PA and PB are tangents. According to CPCT, CPCT means congruence, corresponding parts of a congruent triangle. See, according to CPCT, I can write, as these two triangles are congruent, according to CPCT, I can write that CPA and PB are equal. So the two tangents PA and PB are equal. In this case, first option is the correct. So tangents drawn from external point, P is external point to a circle, okay, OA and OB are radius of a circle, are what? Equal. So we'll move to the next question. A line which touches the circle at one and only one point is, the options are secant, tangent, diameter and radius. To find the correct option, let us discuss with using the diagram. So this is the basic concept of a circles chapter. So the blue line, the blue color one is a line and black color one is a circle. The line is touching the circle at only one point. If a line touches the circle at only one point, is called tangent of a circle. Okay. Whereas a line, suppose I am drawing a line M which is touching the circle at 2 points A and B. In this case, if a line touches the circle at 2 points, the line we call it as secant of a circle. If a line touches the circle at 1 point, it is called tangent. If a line touches the circle in 2 points, it is called secant. Let us see the question. A line which touches the circle at one and only 1 point. If it touches the 1 point, the correct option here is tangent of a circle. So let us move to the third question. The tangents drawn at the extremities of the diameter of a circle are, the four options mentioned in this problem are perpendicular, equal, parallel and intersecting. See here in the picture, AB is the diameter of a circle. Extremities means end. So A and B are the ends of the diameter in a circle. Here there are two tangents, tangent L and tangent M. L is a tangent because it is touching the circle at one point. M is also a tangent, it is touching the circle at B at one point. So the tangents drawn at the extremities of the diameter, I have drawn the tangents at the extremes of the diameter of a circle are. So L and M, so we can easily make out they are parallel to each other. These two tangents are parallel to each other. So correct option for this question is parallel. So we'll move to the fourth question. The question says the number of tangents that can be drawn to a circle from external point R. Okay, in this question, how many tangents we can draw to a circle from external point? Already we discussed in the first question. Here PA and PB are tangents to a circle. Why we are calling tangents? Because this line PA is meeting the circle at only one point, and PP is another tangent. It is touching the circle at only one point B. So you have to make a note, students. Here PO is not a tangent, because if I extend this one PO, it is touching the circle at 2 points. Okay, these 2 points, if a line touches the circle at 2 points, it is not a tangent, we know. Here in the question it's clearly mentioned that number of tangents drawn from external point. P is an external point. How many number of tangents are possible? So now you can easily make out PA is one tangent, PB is another tangent. So the correct options are 2. There are. So this is the angle subtended by the tangents drawn from external point. P is an external point of a circle. Or what? The 4 options given in this are equal, not equal, sometimes equal, not defined. So as we already discussed this type of problem, so there are 2 triangles. PAO is one triangle and POB is another triangle. According to RHS congruency, I can write PAO, triangle PAO is congruent to triangle POB. Okay, as per CPCT, already we know that CPCT stands for corresponding parts of a congruent triangle. I can write that AOP, angle AOP is equal to angle BOP, which means these angles are equal to each other based on CPCT. So the correct option for this question is equal. We'll see the 7th question. In a circle, the angle between the radius and a tangent at the point of contact is, the options are 60, 180, 90 and 360 degrees. This is the basic question in this chapter. We all know that the point of contact of radius, this is the point of contact, C is the point of contact, the point of contact of radius and the tangent. Here this red line is tangent and blue line AC is radius. The point of contact of radius and tangent is always perpendicular to each other. Perpendicular means 90 degrees. So 90 degrees is the correct option for this question. 8th question. 2 concentric circles of radius 5 centimeters and 3 centimeters are drawn. The length of the chord of a large circle which touches the small circle is, so 15, 10, 4, 8 centimeters are the given options. We have to find the length of the chord. Which option is correct in this question? So this is the diagram related to the question concentric circles. We all know that concentric circles. What are concentric circles? Circles which have same center. We call it as concentric circles. Here we have 2 circles. One circle OA with radius and the other circle is OP as a radius. So the 2 circles have the same center O. So now we are going to find the length of the chord. Here the length of the chord is PQ. So we are going to find the PQ in this question. So to find PQ, we have to find the side PA, later AQ. Okay, and once if we add PA and AQ, we will get the length of the chord PQ. So if you clearly see in this picture, there are 2 triangles. OPA is one triangle and OAQ is another triangle. In this triangle OPA, it is a right angle triangle. We all know that radius and the tangent are perpendicular to each other. This is a right angle triangle. In a right angle triangle 5 is the hypotenuse, 3 is the radius and the other side will become 4. Already we discussed the Pythagoras triads, so directly I am writing 3, 5, 4. So coming to back to the second triangle OAQ. In second triangle OAQ, OQ is 5 centimeters because it is the radius of a circle. In a circle all radius will be equal, and OA small circle radius is also given 3 centimeters. So if hypotenuse is 3, OA radius is hypotenuse is 5, radius is 3, other side will become 4 based on the Pythagoras triad. So we know PQ is equal to PA plus AQ. So already we find out PA, which is 4 centimeters, and AQ is also 4. So 4 plus 4 is 8 centimeters. So the length of the chord is 8 centimeters. So correct option here is 8 centimeters. So to find the area of the given quadrilateral, we have to find the area of triangle 1 and area of triangle 2. QOP is one triangle and OPAR is another triangle. So based on the Pythagoras triad, 13, 5 and 12 will be the length of the tangent. So here P is an external point, PQ is 12, PR will also be 12, because there is a theorem which already we discussed. Tangents drawn from external point of a circle are equal 12, 12. So in the first triangle, area we can find out as half into base into height. In this picture, base is PQ, which is nothing but 12 centimeters, and height is 5 centimeters, as it is a right angle triangle. So based on the simple calculations, the area of triangle OPQ, so area of triangle OPQ is equal to 30 square centimeters. Similarly, in the second triangle POR, so area of triangle POR will also be similar 30 square centimeters, because the both triangle are congruent to each other. So to find the area of quadrilateral PQOR, we have to add the two triangles areas. First triangle area is 30, second triangle area is 30. Together is 60 square centimeters. So correct option for this question is 60 square centimeters. I will write D is an external point, DR and DS are tangents, and these tangents are equal because tangents drawn from external point of a circle are equal. So DR is equal to DS, which I will assume it as a third equation. Similarly, C is an external point of a circle, and tangents drawn from external points of a circle are equal, and I will write CR is equal to CQ. So I will add all the four equations. So adding all the four equations, I will have to add all the left side of the equations. So left part of our equations are AP plus BP plus DR plus CR, which is also equal to the right side of the four equations, AS plus BQ plus DS plus CQ. We all know that AP plus BP, here AP plus BP, this together makes AB. So AP plus BP is AB, and DR plus CR. If you see the picture, DR plus CR together makes DC. So instead of DR plus CR, I will write DC. So coming to AS and DS, if you see the picture, AS and DS are nothing but AD. So AS plus DS is AD, and BQ plus CQ is nothing but BC. Therefore, according to the picture, AB plus CD is equal to AD plus BC or BC plus AD. So fourth option is the correct answer for this question.